right, class, welcome back to our lesson on a locus, a set of points. In the previous lesson, we just discussed what is a locus, and hopefully I eased your mind into saying that we've been working with them forever. And then we started talking about some basic elements of a locus that involves visualization, and even if you have a hard time visualizing, just drawing some stuff out. But now what we're going to do is take that concept and make it even more challenging. We're gonna deal with loci, or plural of locus, that have more than one condition. Okay, so now what we're going to do is talk about a locus that has conditions, plural. Now this is going to get interesting. So we'll start with this diagram of two intersecting lines, K and M. And what we're going to do is figure out what is the locus that meets these two conditions. Equidistant from these intersecting lines, that's condition 1, and then also 5 centimeters from their point of intersection, condition 2. Now, if you can't visualize this, and you might not be able to because it's rather challenging, if you can't visualize it, well then let's start from the basics. Let's go with equidistant from intersecting lines K and M. So if this is line K and this is line M, what would be equidistant from each of those lines? Something right in the middle would be equidistant. So like my distance from here would be the same for each line. Okay, that's an equidistant point. Could this also be an equidistant point? Yes, absolutely. So the distance to line M would be congruent to the distance to line K. That's going to be equidistant. And so a set of all points in between. So it's something going like this. But wait, Mr. Katz, you're saying, could there be more? And I would say, absolutely, good eye. Because there might be points down here that are also equidistant. Okay, so there are points, quotes underneath, which you know me, I don't like to have gravity mess with you. There are points underneath that also fit that description. And so we're looking at points equidistant from lines K and M. But wait, you might say. What do you mean, wait? Are there other points that are equidistant? What about these spaces in between here? Why, yes, good eye. If we have a point here, would that not also be equidistant to K and M? So funny how that works. Okay, so we have points that are on the kind of the right-hand side, that space out there. And the same would be true for the left-hand side, the left-hand space. So those two lines that we have drawn in red totally fit equidistant from intersecting lines K and M. But now we have another condition. What about the points 5 centimeters from their intersecting points? Now, we know that the points 5 centimeters from an intersection point is a circle. We should know that from the first video. So all points 5 centimeters from there makes a circle. But remember, this is multiple conditions. Both conditions must be satisfied. So can we draw a circle? Yes, we can. But will it emphasize the point that we're looking for where both conditions are met? No. Here's what we need to establish. We need to establish, let's say this far out is 5 centimeters. Okay, so let's just say this far out from the center is 5 centimeters. And it's already on that first condition. Okay, so it's already on the first condition. Well, similarly, maybe this is also 5 centimeters. That condition's being met. Centimeters wouldn't see. So here's a second point. And the same thing on the line that would maybe 5 centimeters is out this way. So we have a third point out to the left. Again, left in quotation marks. And then lastly, 5 centimeters the distance down. And again, down. So what is the locus then? Right? We have all this picture. We know, let's say it came originally from that circle, the set of all points that are 5 centimeters from there. But the question still remains, what is the locus? I don't even know. Like, all I see is a picture of lines and stuff that you've drawn, Mr. Katz. I still don't get it. So we got to remember what a locus is. It's a set of points that are both equidistant from these intersecting lines and 5 centimeters from the center. So the locus, in fact, is only 4 points. So the locus is only 4 points. It's this point, we'll call that point A, and this point we'll call that point B, and this point we'll call that point C, and this point we'll call that point D. So only those 4 points is the locus of these two conditions. All right, so that's, when we talk about multiple conditions, we have to remember not only fitting each description, but what meets both conditions. So the locus is only the 4 points that satisfy both, 5 centimeters from the intersection and equidistant, because that is the case. Boom, boom, equidistant, boom, boom, equidistant, boom, boom, equidistant, boom, boom, equidistant. So when we talk about multiple conditions, that might take place. So hopefully that was fun for you, because it was awesomely fun for me. All right, speaking of fun for me, space. Oh, no, wait, we're going to draw a locus we got to do more multiple conditions, then we get into space. All right, anyhow. So more multiple conditions. What is a sketch of the locus of points in a plane? That's going to be important, in a plane, 2 dimensions, that satisfy these conditions. Equidistant from 2 points x and y, and then 2 centimeters from the midpoint of segment xy. What? Mr. Katz, I don't get it. You know what? Me neither. So let's begin. 2 points x and y. So let's make 2 points x and y. Okay? Fine. All the points equidistant from those 2 points x and y. So just like we did in the first video and in the previous example, we think of all the points that would be equidistant to both x and y. Right? So all of these points here, how do we know those are equidistant? Because we're thinking, we understand this distance from that point to y is this long, and it's going to be equidistant to x as well. So all of these points satisfy that criteria. Okay, they're equidistant. Okay, so all of these points, they basically make a line. They make a perpendicular bisector, to be honest with you, of that segment if it were there. So that is our first condition. Equidistant from 2 points x and y. That is our first condition. The second condition is 2 centimeters from the midpoint of segment xy. So now we're introducing segment xy. And now we're introducing the midpoint, which, as we know, you should know, is on the original condition, because equidistance. Okay, so the midpoint is on our original condition. But the second locus talks about 2 centimeters from that midpoint. So we imagine, let's say this is 2 centimeters on this side, and this is 2 centimeters on the other side. So there is our second condition, 2 centimeters from the midpoint. Now you might be thinking, but Mr. Katz, it's 2 centimeters from the midpoint. Isn't that going to make a circle? Yeah, it's going to make a circle. So if you want to draw a circle, but these 2 points here do not meet the first condition. The only 2 points that are going to meet the first condition are on the first condition. So if you want to, go ahead and draw your circle. If you want to, go ahead and draw your circle with the 2 centimeter radius. But you still must remember, what is the answer, right? What is the locus? What in fact is the locus? All I see here are lines and circles and stuff. So what will the locus be? This is what you must understand. The locus is only going to be 2 points. They are the points that are 2 centimeters from the midpoint of segment xy and equidistant from xy. So these are the only 2 points, this point A here and this point B here. Those are the only 2 points that satisfy this locus, those 2 conditions. So it's incredibly fun to talk about. All right, so now on to space, the final frontier. So now we're going to talk about loci in space. Oh, so much fun. So what is the locus of points in space that are C units from a point D? It doesn't matter how many units. Let's say, if you say 5 units, it doesn't matter. I don't get it because we're in space. If this was on a plane, hopefully you know we're dealing with a circle. But now we're in space. So we're going to start with point D. So here's our point D. We're thinking space now all the way around. Okay? C units from that point. Okay, so we have our circle. I dig that. That's C units, and that's C units. That's there. But it's in space, right? It could be C units up. It could be C units down. It's all around. This, my friends, is a sphere. So we have to imagine a sphere. And the radius of that sphere is C units. And so I don't know how you want to draw like your sphere. You can do shading and all that stuff that you learned in art class. But you have like your sphere. Oh, that looks like the Death Star. So you have your sphere, but that's what's happening. So when we're talking about a locus in space, you have to consider it could pop out of the paper or down below the paper. So much fun. All right, next example. The locus of points in space, 3 centimeters from a line L. Whoa, what? Line L. All right, so let's make line L. Here's line L. Now remember, we're in space now, ladies and gentlemen. Space could be up, could be down, below the paper, above the paper, and on the paper. So if it's 3 centimeters from line L, okay, well remember we had 3 centimeters this way from our previous video. So basically we had kind of 2 parallel lines, right? That's from the previous video. So in 2 dimensions, it would be 2 parallel lines to L. But this is in 3 dimensions now. So what might we be looking at? Kind of like a tube. What? Yes, because if you have line L through the center of the tube, all of the points in space that are 3 centimeters from it would make basically a never-ending cylinder. And that's what's happening. An open-ended cylinder, never-ending cylinder, however you want to describe it. Call it a tube, I don't care, as long as you can articulate what you're thinking. Okay, but now we're talking about in space. So it would be like an open cylinder, a tube that goes on forever and ever and ever. So much fun. Okay, I love this stuff. All right, on to the last example, and then we'll do a quick quiz. So, locus of points in a plane. So now this question deals with in a plane. That's 2-dimension. Equidistant from 2 parallel lines. So let's make 2 parallel lines. Remember, we're in a plane now. So 2 parallel lines. What's the locus that's equidistant from those 2? Now, what would be equidistant from these 2? Hopefully you realize it's something in between. If you don't realize that, that's unfortunate, because you should realize that. It's something in between. It's going to be equidistant. So the locus would be a parallel line right in between them, right? So that's in a plane. So now the question becomes, what's the locus of points in space now that are equidistant from 2 parallel planes? So now we have to consider parallel planes. So let's draw a plane here. We got to imagine some stuff. Maybe a plane here, and just plane segment anyway. So you imagine like your 2 planes, kind of like a TIE fighter, if you picture that. Again, Star Wars reference. So what would be equidistant from those 2 parallel planes? Hopefully you know it's going to be in between them, because if it's on either side, it's not going to be equidistant. So it's going to be a plane right in between them would be the plane equidistant from them. So hopefully you can see what's happening between 2 dimensions and 3 dimensions. And plus it's a good opportunity to practice artwork. So that's where locus can get kind of crazy. You start envisioning conditions and multiple conditions. And now we'll end on a very quick quiz. This is going to be super quick. What is a sketch for the points in the interior of this angle DEF that are equidistant from the sides of DEF? Okay, so we have DEF and we want equidistant from the sides. So remember, here's a point here. That's going to be the same distance. Oh, here's a point here. It's going to be the same distance. Oh, okay, so it looks like it's going to be something like this, right? Yes. Now, what is the name for that locus? That locus has a name. Do you know what it is? Do you know what it is? Do you give up? You give up? Imagine what that's doing to the angle. It's bisecting it. That is the angle bisector. Okay, so all the way back to the beginning of the year, that's the angle bisector. Is the locus of all points equidistant from the side of that angle? So much fun. All right, last question, and we'll call it a year. What's the description for the midpoints of the radii of a circle with radius 3 centimeters? What? Midpoints of the radius. Okay, so here's our radius is 3 centimeters. Let's make a midpoint. If we have a midpoint here, how long is that distance? It's 1.5 centimeters. I hope you know that. It's half of 3, midpoint, okay? So what's the locus then of all of the midpoints? Hey, it's another circle, because all of the midpoints would make a circle. But now the radius is 1.5 centimeters. So that's exactly what the locus is, a circle with the radius of 1.5 centimeters. Hooray for locus. And that's it for locus. And ladies and gentlemen, that's it for the units on circles. And for my classes, that's it for the year. So peace out. Hope you had fun.